This lesson is on the mole and molar mass. We are not going to be talking about that cute little animal that can't see very well. Okay, we are talking about a mole as in a quantity. So you'll see chemistry jokes a lot with moles pictured like this one. Oh, how cute. Okay, but we're talking about a mole as a quantity. So it's really similar to a dozen. It's telling us how much. A dozen is always 12, regardless of how many things we're talking about. And yes, I know a baker's dozen is 13, but that's not what I was asking. A dozen is 12. A mole, not 12, it's 6.02 times 10 to the 23rd. This is a huge number. I mean, if I wrote it out, it would be 602 and then have 21 zeros. I don't really want to write that. That takes too long. That's why we use scientific notation. So it's an amount and we use it to count things that are really, really, really small, like atoms or molecules. You wouldn't want to measure things or count things that are really large in moles. For instance, if you had a mole of people, I have no idea where they would all fit. I don't even think we could fit on the planet. Um, a mole of pennies, though, wouldn't be too bad. So, this is called Avogadro's number. So Avogadro is the one, Amadeo Avogadro is his name, pretty cool name. He came up with this quantity as a way to measure really small things, like I said, atoms or molecules. So know that this is Avogadro's number. I know it kind of looks like avocado. And here's the unity qualities for it. So 1 mole, you see written here, and no, I did not forget the E. They write MOL as an abbreviation. Apparently, chemists are too lazy to write one more letter. So we write MOL to abbreviate mole. It is always 6.02 times 10 to the 23rd particles. And I want you to make note that a particle could be anything like an atom, a molecule, or what we call a formula unit. And we'll talk more about these in the next video. It also equals the molar mass, which is what we're going to calculate next. So it's the number of grams in 1 mole. So I'll get to that in a second. And it also equals 22.4 liters of a gas at STP. STP stands for standard temperature and pressure. We're going to talk more about what those values are and why we care about them later. For now, just know that 22.4 liters of gas works at only these two temperatures, this temperature and this pressure. Temperature, if you're curious, is 0 Celsius and the pressure is 1 atmosphere. So, atomic mass. We have to go through a couple definitions before we can calculate this molar mass. We got to know what it is. So, atomic mass is the mass of any one atom. And it's relative, so compared to, remember, relative means in this case, it's compared to or relative to the carbon-12 atom. This is the number on the periodic table that we've been using. So this is like an atomic weight, atomic mass, same thing. The unit for it is AMU. And if you're wondering what an AMU is, it's not that hard to figure out. It's an atomic mass unit. Not very creative. So that's just one atom. So for instance, pull out your periodic table. You're going to need it in a minute anyway. If you find copper's atomic number 25, its atomic mass is 63.55. And we always round these to the hundredths place. So maybe let's make a note of that. Round to hundredths place. Oops. So copper is 63.55. Okay. All right, so that's just one atom. Well, what if you have a whole bunch of them? Then you can calculate what's called the formula mass. And this is what we're going to practice doing. It's the sum of all the atomic masses of all the atoms in a compound, measured in AMUs just like atomic mass. So measured in atomic mass units. So this one we'd have, let's say, we wanted to know salt, table salt. Okay, so NaCl. Okay, we've got 1 sodium, we've got 1 chlorine, so we add them up. So sodium is 22.99 plus chlorine's 35.45. Okay, so when you add these up, oops, you get 58.4. I dropped the mic, sorry. 58.44. Okay, and we're going to go through practice this too. So the last thing is what we really want to get to is the molar mass. This is the mass in grams of 1 mole of a substance. So if you have 1 mole, you have 6.02 times 10 to the 23rd particles. Maybe that's molecules, maybe that's atoms, but you have 6.02 times 10 to the 23rd of them. That's 1 mole. This is how much mass it would be. It's the same number as the formula mass. So you add them up, but the unit here is grams per mole. So this is the key, grams per mole. Okay. So how do we calculate this? Okay, we're going to talk about one that's more complicated than something like NaCl. So to calculate the molar mass, first you have to add the mass of each atom. So you have to know how many there are of each atom. Subscripts indicate how many of each atom are in the molecule. A subscript is a little number that's below, sub meaning below, like submarine goes below the water. So if you have H2O, okay, the subscript, the 2, tells you how many there are. If there's no subscript written, it is a 1. Okay, so oxygen just has 1 here. And the subscript always applies to the element right before it. Okay, so in this case, there's 1 hydrogen, or sorry, 2 hydrogens and 1 oxygen. Okay, now some molecules are written with parentheses. If you have parentheses outside of, or sorry, if you have a subscript outside of your parentheses, you multiply, just like you would in math. You always multiply with a number outside parentheses. So if you had, for instance, Mg parentheses, NO3 parentheses taken twice, that 2 would multiply. So in this molecule, I have magnesium, nitrogen, and oxygen. Magnesium, there's no number written after it. There's nothing written right here, so there's only 1 magnesium. Nitrogen, there isn't a number written after it in here, so there's 1 nitrogen in the parentheses, but I have to multiply by 2. This applies to everything inside my molecule, or inside the parentheses. So 2 times 1, sorry, this is a 1. 2 times 1 is 2, so there are 2 nitrogens. Oxygen, well, I have 3 of them in my parentheses, but I have 2 outside, so times 2. So there are 6 oxygens. Another way to think of just this piece with the 2 outside the parentheses, you could think you have 2 groups of NO3. Okay, so you have 2 nitrogens and 6 oxygens, 3 and 3. Okay, so let's do a couple examples. First one, what's the molar mass of H2O? So whenever you're doing these, you're going to want to write out your elements first. I list them vertically. So I'm going to write out hydrogen and oxygen. Okay. Then I'm going to go back and I'm going to say, well, how many of each of them do I have? So I look at my formula. I have 2 after the H. So that means there's 2 hydrogens. I have nothing after the O. That means there's 1 oxygen. So hydrogen I'm going to multiply by its atomic mass. So I look on the periodic table and I look up hydrogen. On your table, it's the red number with the decimals. So I'm going to have 1 number after the decimal. So I'm going to round this to 1.01. So oxygen is 15.999. So I need to round this up to 16. And I'm always going to have 2 numbers up to the decimal, so they are zeros. So for hydrogen, when I multiply, it's 2.02. For oxygen, it's 16. I'm going to take these and I'm going to add them up. So it's 18.02 grams per mole. That's the molar mass of water. Let's do one more with parentheses. So here, oops, sorry. So here I have NH4 taken 3 times PO4. So I'm going to list my elements. I have nitrogen. Whoops. I have hydrogen. I have phosphorus. And I have oxygen. Oops. That's annoying. Okay, nitrogen. There's 1 in the parentheses and a 3 outside, so I have 3 total. Hydrogen, I have 4 in the parentheses, 3 outside, so 4 times 3 is 12. phosphorus, I just have 1, and oxygen, I just have 4. So I have to look up now their atomic masses. So I find nitrogen on my periodic table, and it's 14.0067, so I'm going to round that to 14.01. Hydrogen is 1.01. Phosphorus is 30.973, so I'm going to do 30.97. And oxygen, we just did it before, is 16.00. So I'm going to multiply all these out. So I get 42.03 for nitrogen. Hydrogen, I get 12.12. Phosphorus times 1, 30.97. And oxygen, 16 times 4 is 64. Now notice I kept 2 numbers after the decimal. Okay? So I'm going to now add these up. So in my calculator, I add them up. I should have 2 numbers after the decimal because I'm adding, so I should have 149.12 grams per mole. That's the molar mass of this molecule. You should now do the learning check. You have 2 problems that are just like the 2 I did here as an example.